Ladies and gentlemen, it's time to begin the program again. It's my pleasure to introduce Christopher Lohr from PICO Trading. Christopher?
Thank you, folks. Thank you for the opportunity to speak to you about timing as a service. When I was first approached with this opportunity, it was, I want to say about a month ago, 3 weeks ago, and I looked at the entire slate of presentations, and I looked at all the really deep technical content that was going to be discussed, all the really interesting, cool technology that was going to be talked about, and I didn't see anything on what it meant. What does it mean to you? What does it mean to a consumer of this? What does it mean to actually deploy this technology? What does it mean to engineer, design, build, operate, make sure it's working, make sure it's continually working? I didn't see any of that. So that's what I wanted to make my presentation about. So thank you very much for the opportunity to speak to you about this. First one, design. There are always challenges present when you want to design a new solution, when you want to design a resilient solution, when you want to design a redundant solution, when you want to design a relatively inexpensive solution, when you want to design a solution that's going to meet your compliance requirements, that's going to meet your technical requirements. I chose to use an ITIL-based approach. We would do go through a very rigorous design and engineering process, try to figure out what the best products would be to meet the requirements, go in and do the deployment, figure out the deployment, build the infrastructure, and then go through a rather rigorous permit to operate process. One of the things that we discovered in terms of the permit to operate process for timing as a service is that there is a tremendous dependency on the underlying network infrastructures and the stability thereof in order to provide time as a service. We knew this going into it. We didn't know how sensitive the timing infrastructure would be to the underlying network. We discovered very early on that it was incredibly sensitive. We discovered that you can perform all kinds of redundancy and resiliency and failover testing on the timing infrastructure, the antennas, the cables, the amps, the clocks themselves. But if you don't actually do the dependent testing on the network infrastructures, you're going to have a situation where you're going to lose time in a data center and you're not going to have the ability to feed it from any other data center. So it's kind of it's a corollary to a standard network design, a corollary to a redundant resilient path construct where you really have to pay attention to, if I lose time in Frankfurt, where am I going to source it from? Do I source it from the OMX? Do I source it from Milan? Do I source it from Spain? Do I pull it from the UK? How am I going to get it? How am I going to lose it? When I lose time in Frankfurt, where am I going to pull it from? Once you've overcome those design considerations and once you've actually finished your PTO and once you've got it into production, now you have a problem in terms of, or a challenge in terms of, how do I continually make this product better? How do I continually improve upon the precision of the product? How do I continually improve upon the capabilities of the product? And how do I continually offer my customer a better solution over time than the one they originally signed up for? So we're always looking for new hardware, new vendor, new solution, new network design, new resiliency. It's a fun little exercise to go through, let's put it that way. Some of the challenges that are present in terms of which trade-offs you're going to make in terms of how you're going to build it and how you're going to design it are, you can generally build it, you can choose 2 of 3 items. You can build it fast, you can build it cheap, or you can build it redundant. If you choose fast and cheap, it's not going to be very redundant. You're going to operate just fine for a couple of months, and then you're going to have a problem. Your clients are going to come back, and your customers are going to come back and say, well, it breaks all the time. Why am I doing this? Why am I buying this from you? So you have to actually incorporate a resiliency into the foundational structure. If you build it cheap and slow and resilient, it'll get there, it'll get done. It won't get done very fast. Your clients are going to yell at you because it's not ready yet, it's not mature yet, it's not stable enough yet. And you end up having to decide which 2 are most important to me and which 2 are most important to my customer. One thing I found out is customers never want 2, they want all 3. So the question that I face is, which one am I going to skimp on? Which one am I going to try to account for in some other solution or some other way? And how am I going to account for the one that I don't optimize for in the underlying network dependency and the underlying network infrastructure? That was really the interesting challenge that went out to my design engineers. We decided to overcome the problems associated with solution number 2 based on the fact that we had How are we going to source from an outside network? How are we going to source across region? How are we going to source in region? So rather than have, 2 rubidiums plus a cesium in every site, we decided let's do a rubidium, let's do a quartz, and let's do a cesium in region. That's where we are now. That seems to be working, but it's always something we're looking to improve. Several components are required to be considered when you do this. You have antennas. You have problems with antennas. You have problems with roof space. You have problems with the fact that some venues don't want to give you your own antenna. Some venues want you to share some antenna farm. You're going to have a problem with conduits coming down from the roof into your facility. Some venues are going to want you to run through the same conduits. Some venues are not going to want to have conduit diversity. Some venues don't have conduit diversity. Everybody rides the same conduit. When someone's pulling cable through that conduit, you're going to lose your connection. We've had multiple instances in multiple locations where as clients or as competitors or as customers have added antennas to the existing antenna farm constructs, the consultants or the construction workers who are actually pulling the cables from the roof to the data center sites are actually jostling the existing cable structures. So in the space of 3 days, we lost 4 connections. It was interesting, it was annoying, but it was a really good way of introducing a chaos monkey into the mix. We got to see what happened when our cable failed. We got to see what happened when both of our cables failed. It was a freak incident where I guess a guy on the roof pulled out a set of cables, and he pulled a bunch of cables out, and it actually pulled, I want to say 26 connections out of not just our infrastructure, but other people's infrastructure. It was very unfortunate, and it taught us a lot about how we had to have network resiliency. It taught us a lot about how we had to have network route diversity. It taught us a lot about how we had to source time from multiple locations in order to maintain resiliency. Next issue is clocks. Do you have 1? Do you have 2? Do you have 3? Can you get by with 1? The rubidiums are working well. The oven-baked rubidiums are working better. Quartzes are on the way out. I think the cesiums and the hydrogen masers are now being discussed in terms of an internal PICO solution. We're looking at getting a cesium per region. They're expensive, but they allow you to not care about GPS jamming. They allow you to not care about guano. They allow you to not care about snow and ice. They allow you to enter a situation where you're freewheeling for a considerable amount of time and you don't necessarily have a significant enough problem to deal with. Another issue we have is compliance. How do you define compliance to a standard? One of the things that we've noticed is that as we go to our client base and try to ask them, okay, what do we have in terms of an artifact defined by your compliance department or by the regulators themselves? What is that artifact? What is the proof? What is the required specification or format of the proof that the regulator is requesting? We haven't seen any of that come back. We had our own compliance person take a look at it. She understood the requirements, but she couldn't figure out how to put together the response to the regulatory inquiry if we had one. And I have gone back to multiple clients of ours and asked their compliance departments the same thing. Do you have a standardized format in terms of an artifact response to a query? The answer is no. One of the things that concerns me greatly is that we're not going to have a standard response until there's either a finding of fact as a result of an audit or someone gets fined for non-compliance. I think we're all going to wait until we see what the end result of that action is, and then we're going to create our responses and basically copycat them off of that. I think it would be great if we had a little more guidance in terms of what does it mean in terms of the construction of the artifact. What are the proof points? What is the data content that must be presented? We have proceeded down the path of basically pushing all of the data that we're collecting back to our clients in terms of logging, in terms of health and welfare, in terms of grandmaster failovers, in terms of every possible log file entry we can make or capture in terms of the underlying network, in terms of the clocks, in terms of any kind of time slews that we have. We're just pushing all of that data to our clients. They're in the process of trying to figure out, is that enough? Is it too much? How are they going to pull it down? How are we going to continually produce it and send it out to them? That's a lot of data that we're generating on a daily basis. Do we put it in an FTP repository? Do we send it to them in an email and say, here's your daily, time compliance logs that you're using? That is a very open space, I think, and I think we're all looking for a lot of governance in terms of what the regulators are looking for in terms of that. Talked about this. Talked about this. So this is an interesting problem set. When you are in the process of upgrading, how do you upgrade an engine at 34,000 feet on an aircraft? One of the things that we're struggling with right now is the fact that we have a lot of infrastructure that was put in place 2 years ago. It's time to do a tech refresh. It's time to do a refit. It's time to basically renew the lease items. And what we're seeing is that this infrastructure is so embedded, these devices are so embedded into our infrastructure, in order to absorb an outage is difficult. Our change windows are extremely small. We're limited to, between the FX shutdown 6 o'clock p.m. Friday night until 9 o'clock p.m. Friday night. That's literally the change window to get this stuff done. It's a very, very difficult process. It's a very difficult set of changes to go through. This is the fun part. So when we go into the build process, deploying it is difficult. When you figure out what you want to deploy is a task in and of itself. We have 2 labs. We have a lab in the UK. We have a lab in North America. And when we put equipment in the labs, we found out that it didn't work the way we wanted it to. Found out that some of the interoperability problems that we experienced in the lab, we could predict that we were going to see those in production. We ran into multiple interoperability problems that required us to reduce our vendor selection set down to 1 or 2. One of the bigger solutions we ran into, or the bigger problems we ran into that we had to develop a solution for, was Grandmaster selection. So there's a spec, it's there, everyone says they adhere to it, but when you actually get into the nitty-gritty of doing your failover testing, you find out that there are edge cases across all the different vendors for, you pull a cable or you admin down a port, it doesn't behave the way it's supposed to. I think that's a product maturity interoperability problem that we've seen. Happy to walk people through it at a later session. One of the primary concerns we had was I'd like to have vendor diversity in terms of a solution. I like to have path diversity in terms of network routing. I like to have more than one solution or more than one vendor to provide any kind of functionality. I don't think this is a situation where we can do that right now. Our current solution is predominantly based on one vendor, and that's because we had those interoperability issues. There are 3 vendors who effectively do this well, and they're all here. I think if you pick one of those 3 and go with them globally, you probably have a good shot. I think if you pick a couple of them, you will have some resiliency issues. I think if you try to build a fully meshed solution right now, you're going to have resiliency issues. I think if you pick one vendor and go globally, you'll probably have a better go of it. I think you'll be more successful. I think you'll achieve a higher success rate. You'll achieve a more consistent build quality. You'll be able to operationally support it. Having multiple vendors in the mix right now from an operational perspective is very difficult. The devices themselves are different. The configuration of the devices are different. Trying to train your operational staff to support 2 or 3 different vendors in this space is very difficult. If you include software, you end up with 3 or 4 or 5 different vendors in the space. It's a very technical, very SME required space to be in, and the more you can simplify, the easier it's going to be to actually handle it. So the failover testing that we did was, in a nutshell, difficult. We did failover testing for about a 3-week period. It ran the gamut from a physical device swap out, physical port shutdown, pulling a cable, intentional logical misconfiguration. We thought of everything we possibly could to break the systems. The use case for the chaos monkey tests, I think, was a 26-page document, and we ran through it extensively and repeatedly in order to actually observe the results. What I wanted to do was build an as-built doc and a run doc based on those failover tests that we did. We learned a lot. The one thing we learned above all else was that regardless of how redundant and resilient you make your timing infrastructure, if the underlying network is not matching that level of resiliency, it doesn't matter how good your timing network is. It doesn't matter how good your timing infrastructure is. If you can't deliver time from another data center, you are going to be in trouble, right? The timing devices themselves are good, they're stable, they work. When you have a failure, it's usually not a time clock problem, it's usually an underlying network problem, it's a physical infrastructure problem. You've got a kink in your cable, you lost your antenna cable. It's usually a layer 1 problem going into the timing device. You have to build resiliency off of that. We went through an exhaustive testing protocol, we did. I'm very glad we did, because a lot of the problems, the operational problems that we've had since then, we tested and validated what our response would be during that failover testing, and that just directly resulted in the mean time to restore being remarkably low compared to other troubleshoots. The custom management scripts were a fun requirement because there are so many different clocks in the world. There are so many different grandmasters that we have configured that it's difficult to memorize all of them. We had to do an automated deployment. We had to do an automated deployment of the scripts on the actual Arista devices that we use to serve timeout to the clients. We really had to do take a big step in terms of automation for both the infrastructure deployment as well as the infrastructure operation. One of the key things we noticed is the fact that when you have a problem with a grandmaster, you may or may not know that it's a grandmaster problem right off the bat. You will see some kind of a network anomaly. Your client will call you, they'll call the hotline and will say, hey, I've got a problem, I'm not getting time. They don't know why they're not getting time, they don't know how they're not getting time. Some of them have enough visibility into their network to say, okay, I see a log file, I see a time slew that's above my threshold, I see a grandmaster change, I see that. Most of them are not that sophisticated. Some of them are. The ones that are will call you right up and say, hey, I see this change. Do you see that? Yes, I do. And off you go to the races with the troubleshoot. Some of them call up and say, I just lost time, but I don't know what that means. So developing the custom management scripts was a requirement from an operational perspective. It allows our ops resources who pick up the phone to actually engage in an effective troubleshoot, minute 1, hour 1, instance 1 of a problem, and try to get to an 80% solution. There are times when those custom management scripts don't provide the full solution. That's okay, that's why we have human beings involved. The interoperability testing was part of the failover testing. We did develop some use cases for the scripts based on the fact that we had multiple vendors in the environment. At the end of the day, we ended up pulling out the secondary vendors because we discovered that the level of complexity in terms of operationally supporting it was not worth the requirement, or was not worth the value of having the second vendor in the solution. Antenna challenges. Let me tell you, some venues will not let you have your own antenna. Some venues will only let you have your own antenna after you experience 3 outages and you complain that you've had 3 outages with your shared farm, and then they say, okay, you can go plug an antenna over there. Some venues like to put billboards next to their antennas. Some venues like to put overhanging scaffolding on top of their antennas. Some venues like to put a microwave repeater, an RF repeater, about 26 feet to the left of your antenna farm and completely wipe out all the electronics on the antenna. It happens. It's unfortunate. I think it's basically due to the fact that this is a technology that is new. People are not familiar with it yet. They don't understand the requirements. They don't understand that you can't put a microwave emitter there. They don't understand that you can't put scaffolding on top of it. That's just not something they're used to. I mean, a GPS antenna is about the most innocuous looking thing you'll ever see. To the previous point, it's like a mushroom. It looks like nothing. It looks like it has no value. It looks like it serves no purpose. Yet when it gets covered, all hell breaks loose. Cable issues. One of the first problems we ran into was the signal attenuation and the offset required based on your cable length. We specified a certain length of cable. The venue went in and installed a cable that was 56 meters too long. They didn't bother to tell us they bought a cable that was 56 meters longer than we specified. When we configured the devices, we said this is a 51.2 meter cable. It was 107 point something, and we were off, and we couldn't figure out why we were off. And then we said, okay, we're gonna go get a fluke, we're gonna have you attach one side, and we're gonna have you attach the other side, and we're gonna measure how long the cable is. Oh my goodness, it was 107 meters. Now we know. That happened 4 different times in 3 different venues. This is not a technology that people are familiar with. This is not a technology that people know. This is a very, very technical field. This is a very, very technical space to be in. And I just don't think that what's the best way to say this, the lower echelon workers in this field have caught up to speed in terms of the technical requirements and the skills required to perform their functions. We all have, horror stories of data centers. I talked about antennas getting pulled. I talked about cables being too long. I had a situation where we had the connectors, the resource involved sourced the right cables. The cables got shipped to the data center. The data center tech looked at the box. There were 2 different types of cables. We told him which one to pull. He pulled the other one, plugged it in, didn't work in, didn't connect properly. He tried to force it in, broke the connector on the back of the unit. You can't make this stuff up. FRUs, trying to get spares in a timely manner from vendors in this space is difficult. We've gotten to the point where we're starting to stock shelf spares. We're starting to basically have to deal with the fact that our vendors are unable to respond in a timely enough manner for the sufficient number of shelf spares that we have. I'm over. I'm done. I got the red zeros. Any questions? I'm sorry, I exceeded my time limit. It says 0. Oh, magically I have 4. Now I have 5. Fantastic. Oh, sorry, now's the question time. So I've run through this. Here we go. Questions? Concerns, comments? Love to hear your feedback in terms of what you've done, what your stuff is that's working, what your stuff is that's broken. The fun that I've had with this, I started doing clocks. I started doing timing when I was working for BNP Paribas in 2001. I've seen the space grow up. I've seen it get more technical, but I haven't seen the skill sets for the junior level, the lower echelon resources keep up. I think that the more senior level SMEs are definitely coming up to speed and maintaining their up to speedness. So those of you in the room, good job. I'm just not seeing it at the blue collar level. Are you guys? Am I the only one running into these problems? Some of you are laughing, so I assume you're running into the same problems I am. Victor, you're running the same?
Hi, I just wanted to ask you with your experience in the supposedly PTP-enabled switches and problems that you might have had with them. I mean, it's certainly an issue that we run into a lot. So
Yep.
Curious about your perspective on it.
So we use predominantly Arista, Juniper, and Cisco in our space, or we see predominantly Arista, Juniper, and Cisco. Cisco's have difficulties. Trying to get boundary clocks working on those was a difficult and challenging experience. We basically gave up at some point. The Junipers and the Aristas do it better. I think the fun part with the Aristas is they still have bugs. The nice part about having an Arista or a Juniper is you can actually run some custom scripting on the devices themselves to correct. You can do that, it will work, but they have memory leaks. So you have to be careful what you're doing in terms of managing your Arista and your Juniper plant, because you will cause, as you're collecting the log file information off these devices and as you're persisting it outside for your compliance reporting, you will cause an unknown memory leak and the device will reboot itself. It's a fun little gotcha we ran into. Totally unexpected. Yes, I believe the industry refers to those as an undocumented feature. Yes, you get a free reboot. So when you're running your PTP evaluation script and you're trying to pull all your PTP stats, and if you do it once a minute, about 2.5, 3 weeks into an Arista 7150, it kind of has an issue. Other questions? Nope. Okay. Thank you.